this. All right, we have an ACT review. It says in the figure, if n is a real number greater than 1, what is the value of x in terms of n? So the relationship here is the Pythagorean Theorem. 1 plus x squared is equal to n. When you square root, that's gone. X in terms of n. So we want x equals. We have x squared is equal to n minus 1. So subtract 1 over. Square root both sides. So x is equal to, normally I'd have plus or minus 1, but they only have the plus there. So we won't worry about the minus since it's multiple choice. Number 108, which inequality describes the range of this function? There might be several ways to do this. The one way I would do it is, it goes from -2 to 3. So if I plug in -2, we get 5. So up here at 5, we get this point. Plug in -1, we get 2. Yeah, right there. Plug in 0 and we get 1, so we're down here at 1. And now if I plug in 1, I get 2, so now we're going back up. Well, I'm not going to plug in, I'll just plug in 3 and see how high we go. 1, 2, 3. 9 plus 1 is 10, so we're all the way up here at 10. So here's the graph, and the range goes from 1 to 10, including 1 and I guess it's just going to 10. So this is our only choice. Oh, I guess, oh yeah, we do include 1. I got it. We include 1, but we don't include 10 because they really didn't include the endpoints. There we go. I had to think about it a little bit. 109, which of the following is an even function? I'll make this simple. Even functions have all even powers. 4, 3, that ruins that. 6, 4, 2, and this is really x to the 0. So letter B is the answer. This one ruins that one, and this one ruins that one as far as being an even function. So that's the only one with even powers, all even powers. Which of the following is the domain? There's only 2 problems with domain. Even radicals, denominators. This one has a denominator. So we're going to factor out an x. There we go. That helps a little bit. So x equals 0 is a problem, and when x is 16, that's a problem. So we got to skip over 0 and 16. So that is letter F. Denominators are a problem. We can't have denominators be 0. Find the domain and range for each graph. Domain, what x values do we use to make the graph? So this is going down and to the left. So for domain, we know it's going to the left. So -infinity to 5. We're using all the x values to the left to graph this one. The range, we're using all the y values down to -infinity. So this is -infinity all the way up to a value of 2. On number 4, we're going all the way to the left. So -infinity, and the farthest right x value we use is 3. And it doesn't matter if you use the x values once, twice, 3 times, 10 times. It doesn't matter. If you use them once, we're going to include it. It doesn't matter that it's used more than once. The range, the lowest value is -2. And then we're going all the way up to infinity on this one. On this graph, the domain is from -4 all the way to 3. And we want to include 3. So I'm trying to pay attention to your parentheses and brackets. The range are all the y values that we're using. We're going all the way down to -5, and then all the way up to a value of 2. So all the way up to 2. And we do use that one. So pay attention to parentheses and brackets when you answer these questions. Any questions? Use the graph of each function to find its y-intercept and zeros. Zeros are also x-intercepts. Then find these values algebraically. Well, I mean, you can look at the graph, but I'd rather do this algebraically. Let's look at y-intercepts. Let's look at x-intercepts, which are also zeros of the function. Very simple. I know there's a question on the test that students have a hard time with because I think there's a lot of other stuff going on and you just forget to plug 0 in. Don't forget. That's all. When it's asked for y-intercepts and x-intercepts or zeros, plug zeros in. So when you find y-intercept, you plug 0 in for x. So f of 0 is equal to 0 squared minus 6 times 0 plus 9. And I know that to plug zeros in here, you probably don't have to write it out. I know it's 9, but I want to show you what's going on here. So the y-intercept is 0, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually crossing right there. For x-intercepts, we plug 0 in for y. So 0 equals x squared minus 6x plus 9. So 0, we factor. X minus 3, x minus 3. So x equals 3, that's the 0. So it asks for the 0, so that's actually the 0. If they ask for the x-intercept, then it's 3, 0. So the 0 is 3. The x-intercept is 3, 0. So it doesn't matter how they're asking it, but that's how you'll give your answer. Questions? Don't complicate this thing, and don't forget on the test to just plug 0 in when it asks. I can see the problem in my mind on the ones that students struggle with. Use the graph of each function to test for symmetry with respect to the x-axis, y-axis, and origin. Support the answer numerically. So if it's symmetric over the x-axis, that's an odd function. And f of x has to equal f of negative x. If a function is symmetric over the origin, that is y-axis, my apologies, that's an even function, not odd. This is the odd, my apologies, odd. So f of negative x is equal to negative f of x. This function, if you put a point here and you go through the origin, you get its corresponding point. This is symmetric over the origin. Use the graph to test for symmetry. So symmetric over the origin. Support the answer numerically. Don't do that. We're going to confirm it algebraically. So this says plug negative x into the function, which gives us negative 10 over negative x. That's what it says, f of a negative x. Plug negative x in for x. Then on the right side, it says take the opposite of f of x, which is negative 10 over x. Do the opposite. So negative over negative is a positive, and negative times a negative is a positive. That's proving algebraically that this is an even function. Odd function is what I meant to say. Odd function, not even. Any questions on this? Determine whether relation represents y as a function of x. Write either function or not a function. If I pick any x value over here where the graph exists, there are 2 y values, so it fails what we call the vertical line test. This is not a function. Y has an odd power, so if I solved for y, I would not have to square root or fourth root or sixth root, and I wouldn't have to have plus or minus. Since this power is odd, this is a function. This happens to be a line that's not vertical, so it's a function. So you're looking for odd powers of y on that. Even powers is not a function. Find each function value. F of negative 2 is equal to the square root of 4 minus 3, square root of 1, 1. No problem. We like plugging in values. When you plug in a variable, there's usually a little bit more work. F of a plus 2 is equal to square root of a plus 2 squared minus 3. So we have some algebra to do. We expect you to simplify this stuff. So we would not leave this as a plus 2 squared. We have a squared plus 4a plus 4 minus 3. There's FOIL. A plus 2 times a plus 2. And then all we have left to do is minus 3. Now we're not looking to factor that really unless it factored into the same thing. So the only time we look to factor that is if it would factor into like a plus 1 times a plus 1. That would be a big deal because then you'd have a plus 1 squared and then it would cancel. A plus 1, as a matter of fact, it'd be the absolute value of that. So don't look to factor that unless you think it's going to be the same thing. Then that would be a big deal. Try those two. I already talked about it. I want to see how far you can get on that. State the domain of each function using interval notation. Give it a try. Go. Why negative 1?
Okay.
All right, on the first one, negative x plus 1 has to be greater than 0 or equal to 0. The square root of 0 is 0. That's fine. Now, if we put that in the denominator, then we would not have it equal to 0. So negative x greater than or equal to negative 1, divide by negative 1. So x is less than or equal to 1. So the answer is negative infinity to 1. When you divide by a negative on an inequality, you have to switch the signs. We can't take the square root of negative values. So we got to make what's under the radical bigger than 0. That's positive. We got to keep it positive. Over here, and we already talked about this one, we cannot allow the denominator to be 0. So x cannot be negative 3, x cannot be negative 1. So we're negative infinity to negative 3, negative 3 to negative 1. Those are good values. And then negative 1 to infinity. So there's the domain for that one. Any questions? Can't take the square root of a negative. We got to keep that positive. And that's it for today.